Calc Lesson 3.2, doing some exponential and logistic modeling. Anytime you're doing a population model, you want to take P sub 0 as your initial population, R is expressed as a decimal, and T is time in years. So R, make sure you put the 1 in front of it because you are growing if it's going up. If it's going down, then that's a different set of circumstances. So tell whether the population model P of T equals that is a growth or a decay function. Well, right here tells us what we need to know. 1.021. Well, there's a 1 in front, so that means it's a growth. And then this would be our decimal. So we turn that into percent. So that would be 2.1% growth function. Determine the exponential function with an initial value 10 increasing at a rate of 5% per year. So we're going to go 10 times 1.05 to the t, or to the x. Also write an exponential function with the same initial value. All right, if it's decreasing, we have to go 0.024, but then we have to subtract it from 1. And 1 minus 0.024 is 0.976. So this would be a decay, a decreasing function. Okay? Less than 1 for the value. Suppose a culture of bacteria is put into a petri dish and the culture doubles every hour. Predict when the number of bacteria will reach 35 or 350,000. Well, we can use our calculator. 200, hit enter. Whoops. Hit 200, hit enter, times 2, and then you can hit enter. So that's 1, 2, 3, 4, 5, 6, 7, 8. Between year 7 and year 8, if you do that on your calculator with the last answer function. I could show you that on here as well. So you can go, second quit here. Let's go 200, hit enter, times 2. So that's 1 year, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually, between years 10 and 11. I read that wrong. So it would be between years 10 and 11, somewhere along those lines. We'll be able to get a little more accurate with those as we start doing these exponential functions. Suppose the same number of bacteria doubles every 3 hours. So if before we were doing every hour, now we're going to do it every 3 hours. So wouldn't that be 200 times 2? Before it was to the t, so this one would be to the t over 3. So that one, okay? So instead of doubling every hour, it's doubling every 3 hours. So it's going to take a little while longer than the previous one if it's doubling every hour. Okay, use the population data in the table to predict the population for the year 2000. So we got to get an exponential regression model. I've already put all those in to the calculator. So let's go to stat, edit. Remember, we can't put years in. So I had to start at 1890 as my year 0, and then 10, and so on and so forth. But I typed all those in. And this time we want to go stat, calc. This time we want an exponential regression right there, number 10. Go down and calculate. And there you go. 66.99 is our A, so we'll just round that right up to 67 times 1.014 to the x. So we can see that it's growing, and 1.4% is our growth rate. So if 1890 was our year 0, year 2000 would be 110. So I go to my calculator, 67 times 1.014 to the 110th power comes up to be about 309.21 million. So you can see that the actual population The model predicted a little bit more than what the actual population was. But make sure you know how to find those regression models in your calculator. Okay, day one stuff. A couple other things I want to talk about now with day two. Maximal sustainable population. Exponential growth is unrestricted, but population growth often is not. Growth exponentially, but sometimes it'll approach a limit called the maximum sustainable population, meaning you're going to get to the tops, or you're going to have a cap on how high it can go. So that's going to use our logistic growth function, and that C value at the top, that is going to be your limit to growth. It's never going to get any higher than that. So a high school of 1,500 students, 5 students start a rumor, which spreads logistically by that equation. Okay, T sub 0 is the day it started. How many students have heard the rumor by day 0? So you put 0 in for T. Anything to the 0 power, so if I put 0 in for T, becomes 1. 1 plus 29 is 30. 1,500 divided by 30 is 50. Okay, so 50 students have heard the rumor at the end of the first day, okay? Or at the end of day 0. How long does it take for 1,000 students to hear the rumor? I'm gonna have to build a table, I guess, here. How long does it take for 1,000 students to hear the rumor? So I'm gonna have to go to my calculator here, and it is what? 1,500. This is to build a table. 1,500 divided by, what is it? 1 plus 29 times e to the 0.9x. E is right here. X. 1,500 divided by 1 plus 29 times e to the negative 0.9x. I didn't have it typed in right anyway. 29 e to the negative 0.9x. All right. So we want to build a table. So we're going to go second table set. Let's start at 0 and go up by 1s, which we did. Table. And this isn't working. That's got to be a negative sign. Let's change that. There we go. Now it should work. All right. So we can see that between about day 4 and day 5. Between day 4 and day 5. So for that one, it's going to be between day 4 and day 5. All right. 24. Find the logistic function with an initial value of 12, limit to growth of 60, and passing through the point 124. So I'm going to need to use my logistic equation right there. So it's going to be y equals c over 1 plus a times b to the x. Okay? So the initial value is 12, meaning that that's the point 0, 12. So that's my x and my y initially. Limit to growth is 60. And then the second time the point will be 124. All right. So the first time we will go y equals 12 equals c, which is 60, all over 1 plus a times b to the x. But our first b is 0 because we're going to use that point first. Well, b to the 0 is 1, so that becomes 1 plus a. Okay, then I can cross multiply. 12 times 1 plus a is 12 plus 12a equals 60 if I distribute that. Then 12a equals 48. If I subtract 12, so A is 4. All right, so we found the A value first. So A is 4. All right, to find the B value then, we're going to use this point. So 24 equals 60 over 1 plus 4 times B to the X. This time is B to the first. Well, B to the first is just B. So that's 1 times 4B. We can cross multiply again. So 60 equals 24 plus 24 times 4 is 96B. Subtract 24. So 36 equals 96B. And then 36 divided by 96 is 0.375. So our B value is 0.375. So then if we want to write our final equation here, we found A, we found B. So it's going to look like Y equals 60 times 1 plus 4 times 0.375 to the X. All right, there's one like that on the assignment, and there's one like that, on the quiz as well.